the bulb, okay, when we heat the bulb of the thermometer, the liquid inside the thermometer expands. Okay, suppose if you go from 5 degrees Celsius to 10 degrees Celsius, like there is a change in the change of the temperature of 5 degrees Celsius, and suppose the liquid expands up to the 5 centimeter for that case. Okay, suppose now we change the temperature from 10 degrees Celsius to 15 degrees Celsius. So again there is a change in the temperature of 5 degrees Celsius. In that case also there must be the increase of 5 centimeter of the liquid inside. Okay, so if you have the same increase or same expansion of that liquid for same range of the temperature or same difference of the temperature, then that property is called as the linearity. Okay, if suppose there is no linear expansion of the thermometer or the liquid, then we can say linearity is not there. Suppose for every temperature difference we will get different expansion, then we can say the thermometer is not linear or linearity property is not uh, occurred there. So this is something called the linearity, and you can see this linearity will occur only when we have the constant diameter of the tube, and you can see here the diameter is not fixed, the hole is increasing. Okay, so what will happen, the scale will be not linear. Okay, and we can write down over here what should be the state and explain the effect of this fault on the linearity of the thermometer. So of course it won't be the it won't be linear, it won't be the linear scale. Okay, so linearity will be worse or linearity will be less, you can write down over here, or you can write down not linear or non-linear. So the thermometer won't be linear, that will be the first observation. And once, if you want the correct thermometer, our reading, the marking on the thermometer will be different. Okay, for linear thermometer the markings are on particular, you can say particular length. Suppose 5 centimeter will show you the, suppose 5 degrees Celsius, 10 centimeter will show you the 10 degrees Celsius, 15 centimeter will show you the 15 degrees Celsius. So the marking is also linear. But if our diameter of the hole is not correct or the capillary is not correct, the linearity is affected, and so that we should do the modification in that marking. Okay, so we can have suppose 5 centimeter the 5 degrees Celsius temperature, then for 10 degrees Celsius we may have the only 7 centimeter. Okay, or for 15 degrees Celsius we may have 11 centimeters. So marking will be affected. So why it is affected? Because there is a different diameters of the capillary. Okay, so temperature is not useless in that case. It won't be just the linear. Okay, and the marking has to be modified or written again so that our temperature can be measured. So we can write down over here the movement of the liquid has to be correctly related with the with diameter of capillary. Okay, so the temperature won't be useless, it will only be non-linear. Okay, so marking will not be at particular distance, okay, or fixed difference. So if we change the diameter, the marking will be affected. So the motion of that expansion of the liquid has to be correctly related to the diameter, so we can modify the markings and we can still use the temperature of the substance. So I hope you understood this part C. Now we will see the third question. The question number 3, state what is meant by the specific latent heat of the fusion. or melting of the substance. So we know we had to learn the two kinds of definition, one for the specific heat of the substance, and then second one is for the latent heat of the substance. Okay. So latent heat is used whenever there is a change in the state, like solid to liquid, liquid to solid, or liquid to gas, or gas to uh, liquid. And the fusion word is used when we use the latent heat for the state change, whenever the state is changing from solid to liquid or liquid to solid. Whenever there is a state change, okay, we use the latent heat, and when there is a temperature change, then we use the specific heat of the specific heat capacity. Okay. So in the specific heat capacity we had learned there is no state change. If the temperature is same, if it is liquid then it is liquid, if it is solid then it is solid, if it is a gas then it is a gas. Only there is a change in the temperature. But in case of the latent heat, the state changes. Okay. So in case of latent heat of fusion, state can be changed from solid to liquid or liquid to solid. So what is the definition of that specific latent heat of fusion? So we can write down it is nothing but heat required. It is the heat required to change the state of unit mass of the substance from solid to liquid. Solid to liquid or vice versa. You can also change it from liquid to solid. Okay, so unit mass you can write down also 1 kg or 1 gram. So it is nothing but the heat required. If you have 1 kg of the mass or 1 gram of the mass, and if you want to change the state, right, if you want to change it from solid to liquid or liquid to solid, then amount of heat required is nothing but the latent heat of the fusion. Now the part B of the question. The ice cubes of the total mass 17 gram and at 0 degree Celsius are put into the drink of lemonade of mass 300 gram. All the ice melts as 23,500 joule of thermal energy transferred from the lemonade to the ice. The final temperature of the drink is 0 degrees Celsius. So you can see what is the observation over here. There is the ice which melts. Okay, and when it melts, okay, it acquires 23,500 joule of energy, and the final temperature of the drink is also 0 degrees Celsius. Initial temperature is 0 degrees Celsius, final change is also 0 degrees Celsius. That means what is happening, when the ice melts, that means ice becomes water. Okay, the temperature of the ice and water is same thing. That means there is only state change. There is only state change. And when does this state change occur? When there is the absorption of 23,500 joule of energy, thermal energy, that means nothing but heat. And we know whenever there is only state change, we use the latent heat capacity, okay, or we can use the latent heat. And whenever there is a temperature change, we use the specific heat capacity. Okay, so in this case, calculate the specific latent heat of the fusion of the ice. Fusion means whenever there is a state change between solid or liquid, solid and liquid. So we can use this formula. Q is nothing but mass into L. L is nothing but the specific latent heat. M is nothing but mass. Q is nothing but heat change. So I can use this formula directly over here. So I will write down this formula here. Q is nothing but mass into the latent heat. Okay, we need to calculate what is the latent heat capacity. So I will rearrange this formula. So L will become, it will be Q divided by D small m. So you can put here values. When the ice becomes water, when it acquires the energy of 23,500 joule. So I will write here 26,500 divided by the mass of the ice, that is nothing but the 70 grams. So I can put